How to clone a BMW MSD85 DME with Launch X431, the secret behind data comparison. Hey everyone, this is Hussain, and welcome back to Baabji Motors, your ultimate garage of knowledge for automobile diagnostics, programming tools, and tech mastery. Before we jump under the virtual hood today, here's a quick but important note. This video is purely for educational and informational purposes. Everything shown here is meant to guide technicians, learners, and car enthusiasts. We strictly follow fair use principles. Images, clips, and software mentions belong to their rightful owners. Always follow manufacturer guidelines and local laws before attempting any vehicle work. Now, let me ask you something. Have you ever cloned a DME and thought, it looks fine, but is it really identical? Well, that's exactly what we're putting to the test today, using the Launch X431 and its often overlooked data comparison feature to clone a BMW MSD85 DME the right way. Stick around till the end, because the conclusion might just change the way you approach cloning forever. Let's get right into it. The mission today was to clone the MSD85 DME from a 2014 BMW X6M, a beastly SUV that had been giving its owner quite a headache. The problem? Persistent engine misfires, even after multiple repairs. The plan? Clone the data from the original DME, including both EEPROM, which stores vital security info like the ISN, and flash memory, which holds calibration and operational data, and transfer it to a healthy donor unit. So, what do you need for this operation? Let's gather the tools. You'll need a Launch X431 tablet. Any of these will work. Pro 3S Plus Elite, IMMO Plus, Pad, Pro 5, or even Pro 3. Alongside that, you'll need the Prog 3 programmer, a stable external power supply, and of course, both the original and donor DMEs, both being MSD85 variants. Step 1. Reading the original DME. We started with the IMMO Prog function on the launch device. After selecting DME type MSD85, the tablet displayed the wiring diagram. No need for the MCU3 adapter here. Now, how do you connect the Launch X431 with the MSD85 via Prog 3? It's actually quite straightforward. The launch tablet connects via USB to its interface. That interface then links to the dedicated programmer. Using a custom harness, we connect the programmer to the DME following the pinout. 2 power wires, 2 ground wires, and the CAN high and CAN low lines. Finally, an external power supply is connected to energize the DME. Once everything's in place, it's go time. We connect the ECU, read the chip ID, and then move on to extracting data. First, the EEPROM, which, as mentioned, contains the immobilizer and security data. That read was completed cleanly. Then, the flash memory, which holds the main calibration and operational code. That too read without errors. Both datasets were safely saved to the launch tool. But here's the golden rule. Never trust your first read. So, to be sure, we performed multiple reads of both EEPROM and Flash, and saved them separately with names like original_EEPROM_1 and original_EEPROM_2. Think of it like taking 2 selfies, just in case one's blurry. Step 2. The critical verification step, data comparison. Now, this is where Launch X431 shines brighter than most competitors. After rereading both EEPROM and Flash and saving them under different file names, we use the data comparison function, a tool that's criminally underused but immensely powerful. First, we compared the 2 EEPROM reads. The launch tool confirmed they were identical, a perfect match. That meant our read was stable, consistent, and corruption-free. Next up, we compared the 2 flash reads, and once again, identical results. This step alone builds confidence because it ensures the data you've just captured is a perfect mirror of the original. It's a level of verification many other tools simply don't offer, especially not with this precision. For instance, while the OBDStar and Autel tools have their strengths, they lack this built-in data verification feature. It's like having a friend double-check your work for free and never missing a detail. Step 3. Writing to the donor and the final check. Next, we disconnected the original DME and hooked up the donor MSD85. The first move was to back up its existing EEPROM and Flash data. Because backups are like seat belts, you don't skip them just because you trust your driving. Once that was done, we wrote the original EEPROM and Flash data onto the donor module. But here's where most people stop, and that's a mistake. We performed a verification read right after writing, pulling the data back from the donor to make sure it truly matched the original. And here's where things got interesting. When comparing the EEPROM data, perfect match again. The security data, including the ISN, was cloned successfully. But when we compared the flash memory, the launch tool flagged a minor inconsistency. Oh, so what went wrong? Let's find out. Troubleshooting the flash difference. Naturally, the first suspicion was a random read error. To rule that out, we ran another verification read, and both verification reads were identical. That meant the launch was consistently reading the data as is, no glitch there. After closer inspection, we discovered that the difference was limited to a small, isolated block of memory. This area, most likely, was a protected section of the donor DME that simply couldn't be overwritten, a common design feature to prevent tampering. The good news? This section didn't contain any security-critical data like the ISN, which typically spans a broader memory area. Now, just to compare results, we tested with other tools. The OBDStar DC706 couldn't even connect to the DME, while Autel failed to read the data at all. That's when it hit us. Having a reliable tool with a built-in verification and comparison feature is an absolute game-changer. And yes, for the record, Launch X431 didn't just complete the cloning, it confirmed it. You don't just hope the clone worked, you know it worked. Step 4. The takeaway: confidence through verification. So what's the moral of the story? Cloning isn't just about reading and writing, it's about verifying. Every technician knows that the only thing worse than a failed clone is a clone that looks fine but isn't. Verify your read. Always read twice, compare, and ensure your data is clean and consistent. Verify your write. After flashing to the donor, read it back and compare byte for byte with the source. Know your tools. Launch X431's data comparison isn't just a gimmick. It's a diagnostic safety net that builds confidence and credibility. By including these verification steps in your workflow, you go from hoping your clone worked to knowing it did, minimizing comebacks and earning the trust of every customer, especially in mail-in or remote repair jobs where instant rework isn't possible. And hey, if you ever feel frustrated mid-process, just remember, even the best mechanics occasionally forget to plug in the power supply before blaming the ECU. Happens to the best of us. So, to answer the question from the start, can the Launch X431 truly clone a BMW MSD85 DME with full confidence? Absolutely yes, and the secret weapon is its data comparison feature. In my opinion, Launch nailed it by giving technicians not just a tool, but a way to validate their work, a rare level of transparency in the diagnostic world. Now I'd love to hear from you. Have you tried the data comparison feature on your launch device? Did it help you catch any errors before delivery? Drop your experiences or questions in the comments. Here's a fun fact to close things out. The BMW MSD85 DME doesn't just control your engine's performance. It also manages power delivery with surgical precision, adjusting in milliseconds, faster than you can blink. If you found this guide helpful, let's hit our community challenge, 10,000 likes and 1,000 comments. Drop your feedback, hype this video, and don't forget to subscribe to Baabji Motors for more deep dive tutorials like this. Each like, comment, and share helps us stay on the leaderboard and keep bringing you the best in automotive diagnostics. Thanks for watching till the end. And as always, keep learning, keep exploring, and happy diagnosing.